Okay, I'd like to do another example on defining and invoking functions with parameters and arguments, right? Passing data into the function. For this one, I've downloaded the start code, the Mario Kart item box master from GitHub. Can open that up with code, and we'll look at the main.js. And let's just run this just to see what it looks like. Go live. Oops, opened up on my other screen here. Okay. So the main idea here, right, is we enter a racer position 1 through 12, and then click the item box to simulate. We've got some totals here, right? Oh, got a star, golden mushroom, blah, 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 and the results show up and the totals accumulate. And because we're in position 12, we get a lot more of the good items like bullet bills and golden mushrooms and stars, and less of the bananas and green shells. If we were to change that to number 1, you'll see we start now getting a lot of bananas and green shells and the odd star or golden mushroom. I haven't seen a bullet bill yet. Come on, give me a bullet bill. I think there's only like a 1% chance of getting a bullet bill. It does happen sometimes. Okay, I could spend the whole video clicking here. Seriously, 1% chance. I guess I'd have to do this 100 times. Hey, there it is. Okay, anyway, sorry. Okay, so we can set the racer position, and that'll change the probabilities of what you get. Okay, you can see that in the code here. Here I've got my variables to keep track of the totals, my result element where I add the images. I get the main image, so when I click it, it does this collect item function. Woo, there it goes. Right, collect item function, which is I get the position, and if the position is 1 to 6, I do this. Else, if the position is 7 to 12, I do this. Okay? All right, the first thing I'm going to look at is, actually, let's keep that smaller, is organization. I would like to, so here's our position 1 to 12, right? 45% for banana, 35 green shell, 15 star, 4% mushroom, 1% bullet bill. Whereas when we're farther back, we get better items, right? The probabilities change. Biggest thing I see right here when we talk about functions, right? We talk about organization. The last example I talked about it too. We often have one main function, that's the big boss. My initial thought is I'm going to get rid of this. Cut that, and that should be a function called simulate 1 to 6, like that. So I'm going to have a function down here. Function simulate 1 to 6, like so, and I'm going to paste. Shift-Alt-F to just tab that over properly. So now, right, if the position is, right, that input element, if it's 1 to 6, I'll run this function, which will use these numbers, right, 0.45, and then a 35%, so add 0.35 to get 0.8, 15 to 0.95, 4% to 0.99, and then your last 1% is in here. Okay, and then I could clean this up. Right there it should end. Cut, and we'll define a function called simulate 7 to 12. Like so. Function simulate 7 to 12. Shift-Alt-F. Okay. So now you can see this collect item function is cleaned up. It's the big boss that just says, I'm going to get the position and check what the position is. And if the position is here, I'm going to tell this guy to do his job. And if the position is here, I'm going to tell this guy to do the job. And then down here, these are my helper functions, right, or my worker functions. The big boss told this function to do its job, and it does it with those probabilities. If it's 7 to 12, we do these probabilities. Okay, awesome. So that makes the organization better, defining the functions and invoking them. Let's just make sure that still works. Save it. Position 12, getting good stuff. Position 4, getting more bananas and green shells and stuff. Looks good. Okay, now, so that's organization. Functions are great to help us organize our code, define and invoke. But again, this function, we get a random number, we test it, we do the bananas, green shells. Guess what? This function, we get a random number, we test it, we do the bananas, green shells. They're identical, except for these numbers. Okay, so what I'm going to suggest we can do is let's just do a, sorry, let's keep that in our helper function section. Function simulate item, and we're going to pass in some values. I need 1, 2, 3, 4 numbers. And let's just call these, what do I want to call them? Maybe my interval 1, interval 2, maybe my cutoff. Let's just call it, that sounds good. Let's call it step. Step 1, step 2, step 3, step 4. These are kind of, think of it as a number line, and then there's a step 1, step 2, step 3, step 4. That we're cutting up our probabilities, right? Or maybe, oh, whatever, that's fine. Okay, and then open and close brace. Then I'm going to copy and paste all of this. Copy and paste. And basically, this 0.45 will be my step 1. Right? That'll be for my banana. And actually, maybe I could have done banana, green shell. Actually, maybe that makes more sense. Let's just do here, this is my banana step, my green shell step, my, what's next, star step. I still don't like those step word, but whatever. Variable names are sometimes tough. Golden mushroom step, like so. So it was more of a boundary. Anyway, so banana step will be right here, and then this one will be for the green shell step. The 0.95 will be for the star step, and that 0.99 will be for the golden mushroom step. And then the bullet bill, of course, is just whatever's left. Okay, cool. So now, instead of doing simulate 1 to 6, I'm going to call simulate item, and I'm going to pass in those numbers. So the 1 to 6 was 45% for the banana, so the banana step will be 0.45. I think it was 35% and then 15, so 0.7. 15 would be 0.85. Oh no, hold on. 0.45 plus 0.35 is 0.8. 15 would be 0.95 and then 0.99. Right? Those are my probabilities I'm going to use. Boom, 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 boom. Cool. And then I can reuse that code, simulate item, right? Make this more efficient. And I'm going to use my banana step for that one with 0.05 and then 0.1, 0.35, and 0.7. Okay, so 0.05, 0.1, 0. Oh, I forgot already. 0.35 and then 0.7. 0.35, 0.7. Right, so I'm doing the same function but giving it different values, right? Higher probability for bananas, right? And then your green shells, stars, golden mushrooms, all that stuff. Okay, and then this one has different probability breakdowns, right? The steps, the cutoffs. Okay, which means, here's the efficiency. I don't need these two functions because the work of those two functions is now done by this one function. Right? I don't have to repeat all this code. It's using these variables, and I can control what the values of those variables will be when I invoke or call the function. All right, let's see if that works. Okay, 12 looks good. Looks like we're still getting lots of the good stuff. Change that to 1, and we're getting less of the good stuff. Cool. Okay. I think I got some time here. I want to quickly show you too that now that we have this function, how easy is it to be to say, you know what, actually I want to break this up a little bit differently. I want this to be from 1 to 4 maybe, and I want this to be from 9 to 12, and I'm going to have another one, another category. Position is less than or equal to 5, and position is less than or equal to 8. Right, so 1, 2, 3, 4 will have these probabilities. And now Oops, sorry. And now I can just go simulate item, and I can say, you know what, maybe I want to have 1, 2, 3, 4, there's 5 different items. Maybe I want them to all to be equally likely, right? So that would be 20%. So I need a 0 0.2, 0 0.4, 0 0.6, and a 0 0.8, like so. Right? So I can just reuse this, and I have a new category, and as easy as that, I can say, oh, use these probabilities, now use these probabilities, now use these probabilities. Let's see if that works. Okay, so here we're getting lots of the good stuff. If we go to the 1, we're getting green shells and bananas. And if we go somewhere in the middle, like 6, is that within my boundaries here? Yep, 5 to 8. Oh, Bull Bill, bananas, stars. It looks, yeah, that looks good. It's hard to tell exactly, but it looks like it's much more distributed, right? We're getting, they're equally likely to get all the items. Anyway, the power of functions organization, right? I've got my big event function that's calling the simulate item function, and then the simulate item function is very efficient because we're passing values into it, so we can reuse it with different values, right? Because imagine this, I'd have to have 3 separate functions, each of them this big, right? I've reduced my code by 1/3, so that's pretty cool. Or by 2/3, reduced the code to 1/3 of what it was before. Okay, anyway, that is functions defining and invoking. I think I'll have one more example with some graphics, and then you've got some assignments you can do and stuff like that. I hope this is making sense. Like I said, the main idea, functions are blocks of code. We can pass data into those functions. We execute that block of code when we invoke it. They help with organization and efficiency. Okay, hope that made sense. Take care, and we'll see you in the next video.